Good morning, people. I'm just waiting on the email that says my stream is live before I start because sometimes I start and my stream isn't live. Hmm, am I live? Can anyone see me? Um, yeah, I think I'm live. Let me just confirm my video live. Nothing yet. I'm not seeing no live yet. Just a moment, guys. So I don't want to start presenting before I can confirm that I am live. And it seems as though I'm live. Okay, cool. So, welcome today. Welcome to another stream of mine. And my name is Zach, and I'm an embedded developer based in Cape Town, South Africa. Uh, work with I work in a company called Gaiochos, where we do lots of consulting for lots of embedded projects. So, I belong to a developer group called DevHeads, and I speak to a lot of people on LinkedIn. And something that has come up a lot in the recent times is how to do unit testing, or rather, not even just unit testing, how to do testing in general, and especially testing in general when it concerns embedded products. And so, the aim of today is I'm going to be going through why would you do, first of all, what is unit testing? And then once you understand what is unit testing, why would you do it? When would you do it? And then we'll likely explore some code just to see how it looks like when you use unit tests, and then uh, and see how we can talk about how we can um, apply that in an actual embedded product. I'm going to try, as usual with all my presentations, I'm going to try and keep everything as simple as possible, to explain everything as simple as possible. So I will avoid as many big words as I can. And whatever big words come up in my presentation, I'll try and ensure that I can explain them as best as I can. Feel free to leave any questions in the comments below, and also eh, jump on Discord. There's a Discord link in my live streams. There's You can find me on LinkedIn, you can find me on Reddit, you can find me on LinkedIn, Reddit, and Discord. Those three. So let's talk about what what is unit testing. So, or rather, before we, so I'm kind of confused here. Should I go with the why first? But if I go with the why and I explain to you why you should unit test before you know what unit testing is, it's a bit confusing. But in any case, this is where we started. So, why should you unit test? There's a couple of reasons. When you so Unit testing is sort of like automated. You have automated you write another body of software, a corresponding body of software with your current body of software, and what you do with your current body of software is you write more software on top of it, and then the job of the new body of software that you're writing, which is called testing or tests, the job of that new body of software is to go through the software that you're trying to ship as your product, and this new body of software will go through the software that you're trying to ship, and it will make sure that that software does certain things in a certain way. So things that I expect, it will make sure that things that are expected are done, and things that are not expected are not done. So that is what unit testing is. You basically are writing code to test your other code, and you can have this code test your code anytime, in any circumstance, in any situation. So imagine a situation where you've just made a change, you've just found a bug in your code, and you've just made a change to your code, and you want to check, does does this change I've made affect anything else in the code? This is a good place where you would have something called something like a unit test. Um, you want to make sure that the version of software that you're shipping right now is good. It does not break. It doesn't show passwords. It doesn't do funny stuff. So you basically build a body of software that does all of this for you. And because it can do it over and over again, you can use this body of software to experiment. Um, let's go through these reasons I have. So first of all, just as I explained, you when you have unit tests, you can catch bugs early. What does this mean? If you make a change in your software that causes an unintended consequence, let's say you have me as your junior developer, and I come in and you want me to work on your password algorithm, and at some point I'm hashing the password, but it's visible. Okay. Or I'm hashing the password, but I'm not sure storing the hashed version, and I'm storing the plain text version, and this is ending up in the database. And you can sort of use unit tests to make sure that this doesn't happen. You see? And and this is how you catch bugs early. If you have a body of code that is your product, and you have another body of code that checks this product code as often as possible, you basically introduce many ways of catching errors before they have to be found by a user. So it will go through each case in your code, or each case that you've written tests for, and it will test them for expected behavior, and if they're not, it will report. Okay, so that's the first one, catch bugs early. The second one is to verify code behavior, and this is a point where a lot of us almost get mistaken, because a lot of us end up thinking that if if we build unit tests, then you have if you have unit tests, then you have how do you explain it, correct software. No, this is not the case. Just because you have unit tests doesn't mean you have correct software. So all you're doing with unit tests is you're confirming that your code acts the way you expect it to act. This does not guarantee that you expect your code to act the right way. This does not guarantee that whatever your expectations are the right expectations. Like, say you understood a requirement wrong, you're definitely going to encode the requirement wrong, and you're going to test the requirement wrong. But this doesn't, just because you have a test that is passing does not mean that your code is doing what you intended to do. But it does mean that you can verify your code is doing what you intended to do. So when your intentions and your specifications match, this becomes very powerful, because now you can ship uh, code or software that works properly further. Okay, the next point, preventing regressions. So, what are regressions? Regressions is when you had a feature, and then now this feature is no longer available. In the previous version of the code, whenever someone entered a password and the password needed to be 6 characters, the warning showed. And it showed, hey, you've entered a 5 character password and we don't like this. Please fix it. Okay, cool. Junior developer, a new developer. Junior developer doesn't mean um, In my world, junior developer does not mean you're not an experienced developer. It just means you're new to this code base. You've not experienced this code base. So you're working on a code. You could have 20 years of experience, but you're working on this new code base that you haven't worked on before. So you come in and you could make mistakes that no one else has made just by virtue of you not having experience in this current code base. So if you have a robust framework of unit tests around your code, what you're doing is making sure that every time you ship a new feature, it does not affect all the existing features, and this is called preventing regressions. It doesn't affect uh, it doesn't affect existing features in an adverse way, so that way you can keep building upon. Like I'm sure if you've been in a software team, you've at one time, at the very least, even if it's on your own machine, you've shipped code, then you realize, yes, it fixes something new, but it breaks something else, and that's a regression. And sometimes if you have a code base that is extremely huge, think about the Android open source project, AOSP. This is a kernel built for a general purpose operating system that is Android that we use on our mobile phones. A simple change in one part of that code base could affect something very, like you could make a change to the battery code, and which would end up affecting the antenna code, and which would end up affecting receiving, whether people can receive messages or not. Now, if you don't have unit tests, you would have to manually go through all of these changes every time you make some change before you ship it. And as you manually go through this, you might make mistakes. You're likely to make mistakes, and that you're likely to miss cases. You're likely to miss specific nuanced testing. And so the thing you do is you build another set of code that whose main responsibility is to go through your product code and to make sure that your product code doesn't lose features or doesn't introduce adverse effects. Okay. Simplify debugging. Unit tests are supposed to be loud. What does that mean? When a unit test fails, it's supposed to be loud. It's supposed to tell you where it failed and why it failed. So if you have tests in your code and you're modifying a function, say you're modifying uh, algorithm XYZ version 2 has come out. You need to integrate algorithm XYZ version 2 into your code. You have a function that uses algorithm XYZ to achieve ABC. ABC does not change, but you need to change to XYZ version 2 because version 2 has better security. So what you do is you would change over to version 2, and then you would run your tests and see if anything breaks. And then if nothing breaks, you're likely at the same version and you're covered again. If anything breaks, that means your test will tell you what has broken and where it has broken. And then now you can address these failures specifically, targeted. So it will tell you where it broke and why it broke, and then you can address that. So it simplifies debugging because you don't have to guess around to go find out where something broke so that you can go fix it. Rather, you have a set of code that can come and tell you. Confidence. Having tests will make you have confidence. What does that mean? You're sure that if your tests pass, your code works the way you expect, and because of that, you can ship. So you can ship very confidently, which means you can make changes on Friday evening before the end of the day and ship them because you have confidence that this feature will land and it will work because my unit tests are working, are passing. Okay. So boosting confidence is really good because it increases your speed. It increases it as well as increasing your speed, it increases how much you can try because a confident developer will try more because it's not like you're guessing. If I know the code will tell me exactly how it breaks when it breaks, then I'll just try it because I want to see what happens and I want to see if I can go past this. Then it becomes a it's called a red green cycle in testing when you get into testing. So a red green cycle is where you have a test of you have a unit test for some code. Uh, Ideally, it starts with a failing unit test. A failing unit test means something has not been implemented. So And that's where the concept red green comes from. You start with it being red and then it goes to green. Red is when it's failing, green is when it's passing. Okay, cool. So you start with some code, you start with a test, and then because this test is failing, you implement some code for it, and it tests, it fails again, it's red, and then you implement more code, and at some point it goes green. So red green. And because if you have a red green cycle in your building of code, then you can always, if I can hit the green, I can ship because you know that you covered the features that you want. Okay. Improving design. So because once you start writing tests, it makes you think in a different way. Usually, when you want to write tests, especially unit tests, when you're doing unit tests, you're testing specific functionality individually. So if you have a function that receives two numbers, adds the two numbers, sends the sum of this result somewhere else, you would test that those three separate issues by themselves. Those are three unit tests. Does it receive two numbers and handle them properly? When it adds the two numbers, does it get a correct sum? When it's done adding the two numbers, does it send it to another place correctly? So because because unit tests force you to find specific places in your code to test points, um, in hardware this would be a jig. So a test point is at this point I can test for a certain thing because you're forcibly kind of you're thinking about how to come up with tests of your code as you're doing it. It will make you think in a way that where you break down your implementation into smaller units. Remember, I'm writing a function that I am aware I'm going to test, or rather, I'm writing a test for a function that I'm aware I'm going to implement. Whichever way you want to look at it. Whenever I'm writing the test, I will find little test points. Where if I'm writing the function, I will want to arrange it in smaller chunks so that I can apply those test points and collect my results. Okay. So they are tests. They are other kinds of tests that test your complete system. There's a test called an end-to-end test, which tests your complete system in its own functionality. And then there's a test that's called an integration test, which tests what happens when two small systems are integrated. So if you have a function calling another function, and from the result of that function, sending that function to a different result, this would be an integration test because your code is going through a number of your values and variables are going through a number of functions, and at the end of this all, you're going to test it. So that would be called an integration test. And then we have another set of testing that's called property-based testing. This is the hardest kind of testing, but also it's the one with the most result. Property-based testing is almost like fuzzy testing. This is where you implement tests that tests the properties of your system rather than just testing the it doesn't test that 2 plus 2. If you have a function that tests if you have a function that does addition, a property based testing would test it whether it works with negatives, whether it works with letters, numbers, characters, hieroglyphs. It wants to, it targets a set of properties. And because it has a set of properties, it can generate correct and incorrect input because it knows what properties goes into this. Anyways, property-based testing is pretty cool. It's quite difficult. It's quite advanced. But once you get into it, you start looking at code in a different way, and you're able to sort of come up with thinking about it. Remember, we'll get to test code at the end of this. Test code isn't difficult. What is difficult is how to think about tests and how to apply them and when to apply them. Okay. Another thing, one of the last major benefits of testing or unit testing is documentation. So we've all seen the meme where it goes like, yeah, this is a good one. So uh, I have this box. It's I got it with I got my STM. I got my F4 development board on it. If you notice this board, if we try and treat this board as if we try and treat this board as a what do you call it? We try and treat this board uh, as a document in your as a comment in your code. The first comment will go STM32, and then after a few months, PIC 12 or PIC 14, or I think it's a PIC 16F. Okay, and then after a few months, I'll probably not be using that, and I'll have an NRF on this, and I'll label this NRF and whatever. And whatever. The point is, at some point, the comments the comments in your code become obsolete. The words that at some point the comments in your code will not change with the function. So at some point the function will be updated and the comment will be updated. So documentation, there will be a documentation mismatch. So your documentation will be labeling the function as doing something else while the actual function is doing something else. So how do you make unit test function as documentation? Because a unit test tests how the function works and when it works. Every time the way the function works changes, the unit test will have to change so that it does pass. And this can serve as very good documentation. It's almost like live documentation. If you want to know what this function does, if you read the unit test of this function, it will tell you. Okay, so that's why to unit test. Okay, so let's look at when to unit test. So you know what unit tests are, you know why to do it, but when should you do it? So there's a there's quite a few schools of thought. Some people want to write the code fast and then they do the unit test later. This is quite dangerous, quite difficult, because you never really get once you start shipping, you never really get you never really want to write the tests. Tests are hard. Tests the customer is not going to use this code. It's maybe even more difficult to write than the code itself. Why would I want to write it if I've already confirmed that the thing is working? So if your plan is to implement tests at the end of development, it's going to be difficult, but it's achievable. Some people want to do tests alongside development. So this is like, so there's things like in TDD. So TDD is test driven development. What is test driven development? This is when you write the test, and then from the test we'll do this later, maybe in a few minutes. So you write the test first before you write the implementation, and then you run the test, it fails, and then you start building an implementation so that you can achieve it. Okay, so when to write? During development is a good time. um, Another before we get into the when to actually do the tests themselves, there's also a general when, like at what point in your project. I wouldn't recommend starting writing tests at the beginning of the project. The reason is at the beginning of the project, you're in design mode. You're really trying to find out what is my project going to be doing? What am I, how do I deliver what I want to deliver? And what are the limitations? What are the requirements? And before you're solid on those things, it's almost useless to write unit tests because unit tests use infer from that information and kind of go. So you kind of do want a bit of a stable project, like you already know established inputs, outputs, conditions, factors, all of these things, so that you can build unit tests on that. Okay, so so and this brings us into point two onwards of unit testing. So when you're doing a refactor, you have some code base, you need to rearrange it, you need to move things about, but you're moving things about that are not covered in tests. This is a good point to add unit testing because you're rearranging the code. You might be rearranging the functionality. You might be moving features from this function to that function and such and so. And what you want to do is this is a good chance because you know what the code should do. You know where it should do it now. Where if you're refactoring some code, now that is always a good a chance to put in, yeah, unit tests if they're missing, and if they're not missing, to change them up so that the system uh, reacts accordingly. So when you're refactoring, you might choose to implement the unit test before, and then after, then you have existing code base that needs a refactor. You add the unit test, you do the refactor. The point of this is you have existing code, you add unit test, you check. Okay, you check that you run the unit test after adding them, and it checks that the functionalities as confirmed. Cool. You refactor the code, you run the unit test again. Now you check whether anything has changed, and if nothing has changed, you keep on going. If something has changed and the tests are failing, you go and you hunt this down and you fix it. Okay. Another thing is you have an established code base. You now need to introduce a new feature that changes something. So if you're introducing a new feature, this is a good opportunity to write unit tests, because when you're introducing a new feature to a code base, you usually exactly know what it should do when it should do it. So you have enough information to infer correctly the inputs, outputs, and conditions. So you can add unit tests when you're doing new features. If you're fixing a bug, so your customer just discovered a bug. This is one of the fastest ways to add unit tests to the most important parts of your code when fixing bugs. Whenever you have a bug that has been discovered by a user of the code rather than someone who's developing the code, it's always a good practice to cover that new fix with unit tests. This, number one, this guarantees you that future versions of the code will always respect this, because it's clearly something users need and use. And then you also want to, that confidence that we talked about, you want to instill confidence in yourself that you have actually fixed the bug. So whenever you're fixing a bug, it's always good to cover the new feature that you have introduced with some unit tests. If you have a CI/CD pipeline, so that is a continuous integration and a continuous deployment pipeline. This is where you have lots of developers, Android open source again, and all of your developers are pushing up code into GitHub, and they're pushing on different features. Some people are working on version 20, some people are working on version 14, but all code is going up. And you have this set of you have what you want to do is you want to have tests that can break down pieces of the code, test it individually on different platforms. This works on Ubuntu, this works on Samsung, this works on all. You can do all of this with unit testing and frameworks. And so in your integration pipelines, if you have continuous shipping, which means you don't wait for Fridays to ship the features that you wrote this week, you just ship them as they come up, ship them as they come up. If you have a system like that, in this pipeline, it would be very advantageous to have unit tests, because then you can test things as they come up. If you're confident in them, ship them as units and just keep shipping as much as possible. Okay. Uh, that is when to unit test. I'm gonna quickly check YouTube live if we have any questions. If anyone has any questions, please push them up. Uh, I think Melta and Marvin probably are watching. If you guys are watching, you can give me a thumbs up. Good. So as we wait for those people to reply, let's keep on going. So next. So this is sort of a recap, because I want this to be sort of a primer video where you come away understanding what unit testing is, what you can go Google, what you can go find out, and then how you can go through this. So as we've as we've explained, the goal of unit testing is to ensure that each part of your function, each part of your system functions as intended. And then you want to, as you're testing these parts of your system, you want to separate these parts from the rest of the system. So if you're just testing the addition function, you want to test that the addition function is working without checking the multiplication and the subtraction function. Okay, so unit tests are automated. They run quickly and they provide immediate feedback. Um, they validate that output matches expectations for given inputs, and they help us catch regressions. And they help us make sure we don't go backwards, and they ensure that if we have a new change or a new feature, they don't break. This new change or feature does not break what we have already. Okay. They give confidence in the code, making debugging easier and serve as a major form of documentation. Yeah. Uh, Dhruv Melta just replied, says thumbs up. Let me keep going. I'm actually doing most of this for him, to be honest. Okay, let's see. So what's the next thing? Okay, cool. So we now know what unit testing is. Okay, we understand when to use it. We understand why to use it. What do you need in order to use a unit test? Okay, so you can you can't implement unit tests without a test framework, and this will be by once you get into the code, you'll see. But this would be by writing the functions that test your code by themselves and having them run and observing them. However, test frameworks, things like GoogleTest, things like CPP unit, things like JUnit, things like PHP unit. Basically, it's called an X unit, X being the X X unit. So X being the whatever precursor you put onto the unit testing framework. Those frameworks give you test case management. What is a test case? Test case is when you're testing addition does addition, just one part. Okay. They provide things called assertions. Assertions is like, are these two things equal? Are these two things not equal? Is this thing capitalized? Is this thing not capitalized? So you have assertions that say it's almost like a predicate. It's false is false is true. Is false is true is a predicate. Anything that returns true or false is a predicate. So assertions are predicate functions. You give them inputs, and depending on the value of the inputs and what the assertion should do, they do. They reply up based upon that. Some unit test frameworks will have refusions, or rather a refute. Refute is to make sure they're not equal. Okay, make sure these things are not the same. uh, just some frameworks call things the same assertions, and things that are make sure things are different refute. This is especially Elixir and Erlang ones. Okay. Another feature that test frameworks will have is test execution. You'll likely have features to enable you to run all tests, one test, filter the test, just a failing test, just a flaky test, whichever one. Yeah. And then we have set up and tear down. Sometimes your functions need special situations or unique situations before they work. This kind of time is like your function collects something from in-memory cache, and then it does something with that something in-memory cache, and then that's the thing it uses. You've cached, so let's say you have a rate limiting system, and your rate limiting system checks when someone has had more than 100 requests in a second, and you want to test this. You don't want to do 100 tests, 100 calls to your function so that your function can cache 100 calls and then um, report that, oh yeah, yes, when you get to 100 I stop you, or when you get to 100 you go back. So what you do is you have something called setup, where in memory, in the cache, in the RAM, you put in a value like 99, and then you call the function twice. The first one 100, the second one 101. And then basically that gives you the situation where someone has called the function 100 times, and then you can check whether your rate limiter reacts the way it should be or not. So setup is where we make a little pocket environment that simulates some situations, and we want to generate um, generate input or output based on this situation. So, and tear down is to remove those things. So if you have a test that checks your rate limiter, you would want to check that at 100 it rate limits. But if I have 50, it doesn't rate limit me. So what you will do is in setup, you will make it 99 or 100, and then you'll try, and then you'll assert or refute that the call is handled. And then after the test, because you don't want the next test to be affected by this data that you've just put in, you will do teardown. Teardown is resetting. It's like reset the system back to where it was so that I can now test something in isolation. Remember, we are trying to test things in isolation. And isolation means like we have to set up an environment where this thing happened by itself and then we test it by itself. It's not being affected by some other cache, some other memory, some other RAM, some other flash. It needs the system needs to be clean whenever you're testing each thing. Okay, mocking. Uh, Back to the rate limit example. You have a system that rate limits network calls. Cool. If you have a system that rate limits network calls, and you want to check that every time a network call happens, it counts, you would not want to do a network call every time you want to test that the network call is being counted. So what you want to do is you want to provide a mocking service or a pretend service. And that pretend service pretends like it's called the network. It's called the network. It's called the network. And this service is called a mock. Or you want a function that always returns an integer. One of the stages in your code always returns an integer or should always return an integer. So, but you don't want to test that stage you don't want to, stage 5 returns a integer which stage 6 uses, but you're testing stage 6. You don't want to always call stage 5 so that it can give you the integer. What you want to do is to be able to mock stage 5 so that you don't test, you don't, you want to test stage 6 in isolation. So you don't want any input from stage 5. You just basically want to make sure that what the thing that you hand in to stage 6 is the correct one. So that's testing stage 6 in isolation by itself. And then quite a few of these test frameworks will come with integrations into existing build systems. And these build systems will, it's something like CMake or whichever IDE you're using, or West for Zephyr. Um, Test frameworks will come with integration into this build system so that you have something like make test, make build, make, instead of make build, you can do make test and make run and stuff of sort, make sort and stuff of sort, and such. So you do want these test frameworks to be integrated with your build systems, because anyways in integration you're going in CI and CD you're going to use your build systems in order to run the test and such and such and such and so on and so forth. Okay, cool. Oh, amazing. 40 minutes in, we've gotten to explore some unit testing with Google Test. So before I go into this, so let me introduce you to what Google Test is. Google Test. So what is Google Test? Google Test is a testing and mocking framework. Where's that link? Yeah. So ooh, maybe let's go here so that we can see. Yeah, let's look at the primer. So it's a test framework, as I've explained. You can use it for C and C++ code. Uh, it helps you to do the things that we've explained, make independent and repeatable tests, makes enables you to have your tests organized, and you can also arrange them so that they reflect the structure of your project, makes your tests portable, reusable. That means you can run your tests on whichever platform that you need to, and this is usually very helpful when you're doing CI and CD. You have a version of your chip that runs on your on an NRF52, and then you have another version of your code that runs on an NRF91, and you want to write tests. It's the same system, but one system is bigger than the other, but the test is the same. So you want tests that can run on different environments. So that's why they're portable. And then, as you can see, when tests fail, they provide as much information about the problem as possible. And then basically, it's a good test framework. That's why I'm using it today. Okay. Um, you can go through the CMake Quick Start to see how to start it, to set up a project. It's basically, you basically can copy from this online onto your machine. And actually, let's use this as a guide. You basically need to make a little make file, and then you need to fetch what you need to get from your make file. And then once you have that, you can add this to your make file to make it run, and then we can implement a simple test. Okay, so cool. Let's go look at an example test. Plus plus so people can see. Okay, cool. So I'll try and put in a thing here so that the comments disappear. So here is the function that this part is a test case. This part is a test case. A test case is a group of individual tests that test one collective one that test one group of something. Okay, cool. So here we have basic assertions. Basically, this is as you saw on the Google thing. So this is expect strings not equal. So hello and world should not be equal. Expect equal 8 times 9 should be 72. Okay, and then this is now this is a new test for uh, now I have a function here. It's just a normal C function. It's multiply A and B and returns A. So this is a failing one. So if I pass in multiply A and B here, I should be getting 36. Okay. So let's go here. Let's build this. No. Let's build this and see if it works. And then we can start from there. So CMake, not that one. Yeah, let's build. Okay. CMake, build. Okay. cd build, C test. Let's run the test. Okay, cool. So what's happening here? One test failed out of two. Okay, you can see. So let me blah blah blah. So we can see again. Cool. So we have hello test basic assertion passed 0.0 second. Multiply test basic assertion failed. You see. So it gives me. I have two tests. So remember, I have two tests here. Okay. So it gives me two tests. So what do we have? Now, what I'm trying to replicate here is a red-green cycle. Watch this. So remember, we want to test what is failing here. We have reds. Amazing. Red. We started with the red. Okay. So what is failing here? It's saying test one, hello test, basic assertion passed. Test two, multiply test, basic assertion failed. Cool, that didn't work. So let's fix this. Why isn't this? Multiply test, basic assertions, expect equal, multiply 6 by 6 should be 36. Let's come and look at this. Int multiply A plus int B return A. That's where our problem is. It returned A instead of doing this. So let us modify this and we shall do int A times B, return that. Cool. So let's do that. So we have our first, I like doing this so that the warnings disappear. So we have our first thread. Let's come back. Let's build our code and then see what happens. Make build. Make build. Okay. cd build. Okay. C test. Amazing. Look, green. Okay. 100% test pass. There you go. So, and we have a red here. 50% test pass, one test fail. Okay, cool. So what have we done? We've replicated a red-green cycle. So this could be let's name a function. Let's name a function better here. uh, applies low pass. Okay, int low 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 pass filter. So you want, whenever you have an integer c come through here, you want for re, re, return c for now. Okay. I'm going to really disrespect this code, disrespect this, and just write a very simplistic thing. But my my intention is to um, my intention is to demonstrate how to go through this rather than actually building a low pass filter and testing it. LP filter test. Okay, basic assertions. That's fine. I'll use that for now. And then I'll expect expect EQ EQ. So if I do low pass filter, all right, and then I say give me 40, if I say give me 42, I should get 40 because my low pass filter will just take will just take what will it do? My low pass filter, my low pass filter just subtracts 2 from whatever value you give it. So let's quickly do a red green here, and then we'll see. See, make let's again push, okay, and cd build, and then c test. Let's see. Ha! So we have two tests passing, okay, and then one failed. So see, we're introducing a new feature, okay? We're introducing a new feature. Now, what do we do here? We're introducing a new feature, so this is a good chance. We're introducing a low pass filter, and we know how it should work. So we write a test for it, we write a stub for it, we test fails, and then we go back, and then let's now implement this. And then we can do return c minus 2. Okay, cool. Let's go back. Let's build. Okay, let's build again. Let's push into the build. Sorry. Target cd build. And then we do c test. Boom. So what am I demonstrating here? As we're adding functionality into our application, we're adding tests with it. And what is going on here? So next time my manager comes to me and they ask me, is it done? I can just run my test and I can be like, no, I have a few failing tests. And this failing, I've actually quite a few times in my career, I hand over the failing tests as my report. And I as my report for the week of the work, for the work week, yeah, week of work. I would hand in. I've been consulting with clients, and a lot of times they want me to. I do this thing, so I write a bunch of tests, and then each week I send them the test results. And what they're seeing is last week we had 50 failing tests. This week we have 45. Next week we have 40, and so on and so forth. And what's happening is I'm building confidence. I'm reporting in a way, and they know which specific parts are broken. I know which specific parts are broken, and so on and so forth. And I didn't want to make such a very complicated and very involved demo. What I wanted today was to just communicate why you would do unit testing, when you would do unit testing, and how you would do unit testing. And I believe I've shown this. I can prepare more in-depth unit testing scenarios, something that shows actual maybe embedded code that goes into a device that works, or maybe we can do something with Zephyr at some point. Um, but what I'm trying to show here is the things we did today. We understood what unit tests are, when you would use them, how would you use them, and then we looked at a simple example on how to do them. And I think that is mainly what I wanted to achieve today for this hour, and I've been very pleased to bring this to you. And I'll hang out a bit. If anyone has any questions, you can push them on the Discord, you can push them on the YouTube, and you can always, if you're watching this after the fact, after it's been recorded and shared, feel free to leave questions in the comments and let me know what you think. Um, yeah, Melta, do you have any more? Do you have any questions? You can push a question since I'm doing this basically for you. Uh, if you have any questions about what I've said before I hang up, you can push them through to chat now, and I can try and address them. Or Drew, should I call you Drew or Melta? I'll ask you on Discord. Okay, let me check Discord for questions. Wait for questions on YouTube. Ah, okay, cool. So nothing much. Amazing. Was this helpful? I'm so happy. This is so cool. Making for an audience of one uh, is really cool because then you actually unintentionally make it for a very big audience. Making for an audience of one is really cool because then you can really focus on what they want and kind of give them what it is. It's been really nice streaming today, showing you guys about unit testing and how you would use it, and happy to work with you. And thank you everyone for coming to this stream. And uh, before I did. Um, yeah, Melta, I can explain mocking with an example. So let's see. So let's look in here. Let's say this, I'll give you an example. Let's make a new function. Uh, int send information. So first of all, let me label this test code. Typically, typic, typically, the below code lives separately from the above code. In this in this instance, I am keeping them in the same module for ease of learning. Okay, cool. So now that we've established that, let's do a mocking example. So let's do a mocking example. So this as we've established, this this the below application code. So this section of the code lives in application, and this section of the code is in how do you say it? This section of the code is in testing. Send information is a function that takes int d, and then goes something like con int c int constant. It uses a global, some global. Let's define a global here. Let's define a global int int n equals 10. So this function takes int d, okay, and then it does takes int d, and then it takes in here it does um, multiply multiply D and N, okay? And then it says int stage 1, okay? And then int stage 2 equals low pass filter stage 1. Okay, so this is going to be some sort of function in your code, and it has all those three. Okay, cool. So when you do get to testing here, say you want to implement a test uh, send info test. It's just basic assertions. Okay, as you do, and then you want to do expect EQ send information 44, and then you want to do 45, whatever. It doesn't matter. This won't work because this is broken. This is like it doesn't work. Okay, so here's I'm going to say the below invocation needs a mock for multiply and low pass filter. So when I'm testing here in line number 57, remember we said we want to test lines of code. We want to test functionality in isolation. So when I'm testing send information, I don't want send information to be affected by low pass filter or multiply. So what I do is I create mock versions of multiply and low pass filter, and then I would instruct my I would instruct my how do I say this? So I would instruct my test when it's testing send information to use mock a mock of this. And usually the way you do it is you would do something in with Google Test. You would do something like, I think, um, mock method, and then you would provide your method, and then so this would be something like low pass filter, and then here you would do mocker. So yeah, something like that, mocker. Okay, so this is pseudocode. It doesn't mocker func. Don't expect this to work exactly as I type it. So what is happening here? I want to test send information here. Oh yeah, let's sorry about this. Let's do this. I want to test send information, but when I'm testing send information, I don't want it to use low pass filter or multiply, because those, if I use them, then I'm not testing something independently. So I provide a mock method. A mock method is whenever function X is called, provide this value. So mock it. Don't call it, but provide this value. That way, I know whenever I'm looking at the results of testing send information, I know that I'm looking at just send information, and this has only been affected by send information and not just not leaking abstractions or leaking effects from multiply and low pass filter. Does that make mocking simpler to understand? Um, I'm looking at the comments. I'm waiting for Dhruv or Melta. to reply. He probably told me what I should call him. Yeah, he's not there. Ah, yeah. He says, I see. Okay, cool. Yeah, so that's basically how mocking works and why it works and such. Um, so thank you all so much for coming to this. Thank you so much, Malta, for questions. I really like hanging out and asking questions and answering other questions. And that was amazing. And cheers, everyone. I'll see everyone next time, and I'm happy to do this. Let me know if you have any questions or if you want to see me do any sessions and what I can do. And thank you all so much for coming, and cheers. We'll catch you on the flip side. Cheers, everyone. Amazing.